Good afternoon, everyone. Mr. Bencharsky back again here at West St. Paul. We are going to be going into our second of 3 lessons for our final unit on continental drift, which will wrap up our major unit on the Earth's crust. Now, the pictures that we've been looking at since day one, we've got them all now. We have Santorini, Greece, with the island of Atlantis, the volcano blowing it apart. We have a shield volcano eruption of lava and then slow seeping lava over the sides. We have a steel railroad track that was built on a fault line and was bent most likely by a magnitude 7 or higher earthquake. We have a seismogram with our primary waves, our secondary waves, and our L waves or long waves. We have the 4 layers of the Earth: the crust, the mantle, the inner core, the outer core, and we have the supercontinent of Pangaea that Alfred Wegener proposed 200 million years ago. So if you remember last week, we talked about Alfred Wegener, who came up with his ideas during World War I about the continents being together 200 million years ago and breaking apart. And he had 4 pieces of evidence. The first was puzzle pieces. The continents looked like they fit together, specifically South America and Africa. His second evidence was fossil evidence. Fossils of plants and animals on multiple different continents were found, even though there was no way for those animals to get across, i.e. they didn't fly or swim. The third piece of evidence was mountain chains. The Appalachians and the Ural Mountains in Europe look like they connect together. And finally, climate evidence. There was evidence that there were at one point glaciers near the equator and tropical plants at the poles. But again, Alfred Wegener's theory was rejected because he couldn't prove what caused the continents to move. Well, as the title might suggest, Continental Drift Reborn, well, we have to wait till a little bit later for Alfred Wegener's ideas to come back again. Now, after World War II, which ended in 1945, after World War II, many new discoveries were made which forced scientists to revisit Wegener's ideas. So war is not, generally speaking, good for a lot of things, but one thing it is good for is technology. A lot of new technologies are created during the wars. And because of that, we often get new scientific discoveries. One of the most interesting scientific discoveries, which was essentially originally going to be used in military technologies, was the MRI, magnetic resonance imaging, which we now use in medicine it's our best way of knowing what's going on inside our bodies. So many ideas start as ideas used for wars and often find practical uses. So here we go. World War II is no exception. There's some new technologies that are created, and 2 of these really make people go back to revisit this idea that the Earth is moving. And the 2 main inventions were as follows. The first one was called sonar. Now, sonar is, if you've ever gone fishing, you might have heard of sonar before. If you haven't, this might be new for you. So sonar is a technology that sends out sound waves and then they bounce back. And a simple way to look at it is just using boats. So in World War I, the Germans had a number of these what were called U-boats or underwater boats. We might call them submarines. And these submarines were wreaking havoc on the American and British fleets. They were sinking these ships because the Americans and the Brits could not detect them. So a technology was created called sonar. And what it would do was it would send a sound wave to the bottom of the ocean, and if it bounced back before the depth of the ocean, they would know that there was a ship there, so they could rather drop some bombs down to destroy it, or they can get out of its way. Now, sonar became practical after the war in things like fish finding, where it would bounce signals back, and of course, one signal would come back before the other, showing you that there's something there. So it's a very useful technology. It works the same as echolocation in bats and other animals. So certain animals are able to send out sound waves like bats that will bounce back so they know something's in front of them. So bats use echolocation the same way we use sonar. It's also the same way that doctors and nurses use it to find images of inside your stomach, like an ultrasound. If you've ever had a sibling, a younger sibling, and maybe you went with mom to the ultrasound, they put a little imager on the stomach that bounces back and sends us a picture of what the inside of the the stomach looks like. Now, this lets soldiers see submarines under the waves, and after the war, it made scientists map the ocean floor. So the beautiful thing about sonar was after the war was over and they weren't using it to find German submarines, they were using it to map out the ocean floor by seeing how deep the ocean floor was. A map of the ocean. Now, up until this time, scientists knew more about the moon or any of the other planets than they did about the bottom of the ocean. In the 1940s, we weren't able to dive deep enough to get to the depths of the ocean. Therefore, we didn't really know what was going on there. And what they found with the use of sonar was so unexpected. This was what was called a wow moment for all the scientists on Earth as these ships started scouring the planet using sonar to map out the depth of the ocean. What they found was on the bottom of the ocean, they found the largest volcano and mountain chain on the planet. 45,000 kilometers long and 3,000 meters tall, stretching around the world. So they found a massive chain of mountains and volcanoes stretching all along the world. These were taller than any mountain and also longer. And you can see those right there in the red. Now, I believe on your sheet it has a little map. So you can use your red to go over this. So this is the world's longest mountain chain. So if someone asked you, hey, kid, where's the world's longest mountain chain? Well, you tell them under the water. Not like anyone would ever ask you that, but, you know, hey, maybe they will. It's like a giant network of cracks circling the Earth. And we call these mountain chains ocean ridges. So when we have mountains under the water, we don't call them mountains, we call them ridges. Now something's interesting here. Wasn't there some scientist who thought that South America and Africa were once joined, but then drifted apart? Isn't it weird that we found a crack at the bottom of the ocean directly between these two continents? Suddenly, Alfred Wegener didn't look so silly anymore. So remember, Wegener told us about 30 years prior that North and South America, or South America and Africa, were separated. Sorry, my camera is really giving me trouble today. It just seems to want to keep going down for some reason. Hopefully that's better. And because of that, they were once together and they split apart. Well, now with the invention of sonar, we find out that directly between South America and Africa is a massive crack of mountains. That just seems strange. They also found what are called trenches. Now, these are the opposite of mountains. They are deep, deep canyons that go down into the Earth's crust. The largest one in the world is the Marianas Trench, which is just off the coast of the Philippines. And inside Marianas Trench is a place we talked about early back in September called Challenger Deep, the deepest place on the planet. Now, here are the major trenches of the world. Not as many as ridges, that's for sure. And mostly in the Pacific Ocean. Now, there was one more invention. Because even though Sorry, there was a bit of an interruption with my camera there. So I think we left off that the Earth's crust is broken into giant jigsaw puzzles, which slowly move over time. Earthquakes, volcanoes, and mountains occur along the edges, so along the fault lines or boundaries of these plates is where we get earthquakes, volcanoes, and, of course, mountains. So here's, for example, common places we see earthquakes. Here's volcanoes. And there's our mountains. Now, this new theory was called the theory of plate tectonics. So we don't often say the theory of continental drift anymore because it's given that the continents are drifting. We call this the theory of plate tectonics now. Now, Alfred Wegener was right all along. He couldn't figure out how the continents moved because all the clues were buried at the bottom of the ocean, and he didn't have sonar or oil drilling ships to help back up his theory. And a little comic to end it off. And otherwise, guys, that is it for this unit on Continental Drift Reborn. The last little mini lesson is on what we call the theory of plate tectonics. So we're going to get a bit more into those major plates and why, and just a few more questions we can look at before we wrap up our unit on the Earth's crust. We're also going to look at sort of the history of the Earth a little bit, which will include a short film as well as a small project you'll be doing in groups of 5. Yes, you can work together in groups of 5. You can all do your own parts, submit them, and then I could put them together at the end. So either way, guys, we will talk to you next time. See you later. Looking like Wegener's right. Still not 100% convinced, a lot of scientists, until something happened. Now, after the war, there needed to be more oil. World War II had eaten up so much of the world's oil supply that most countries started drilling offshore to find oil. The only place left, because they had already exposed all of their land oil, was to start digging in the ocean. Now, the fact that they've mapped out the ocean really helped. And they invented new ships. So the second invention was oil drilling ships. This is one of those ships called the Glomar Challenger. Now, this was a ship that was able to drill to the bottom of the ocean. And what they did is they took rock samples. So while they were drilling, they were taking samples of rocks. So they were drilling to see if there was oil, but while they were doing that, they were bringing up rocks for geologists to study. And scientists wanted to know how old the ocean floor was, which was the reason why they were taking rock samples. And these oil drilling ships allowed them to do this. Now, just like the ocean ridges, what they found surprised everyone. Most scientists had expected that the crust at the bottom was all going to be the same age. Now, you might say to yourself, how do you date rocks? Well, there is a way to do it. It's not an exact science, and what I mean by that is you're not going to get it to the exact year. But by studying what are often called sedimentary rocks, which are rocks that pile on top of each other, we can get an idea of how old or how many layers down the Earth happens to be, because we know how long it takes these rocks to form sedimentary rocks. But that's not what they discovered. The Earth was not all the same age. And here's a great sort of demonstration. So here is what's called the Atlantic Ridge. So this is a ocean ridge or a large mountain chain of volcanoes and mountains that stretch all between, here's Africa and here's North America. Here's Nova Scotia here. Now, let's take a look at the rocks. Now, each one of these is from a dig site. So let's look here. These are the rocks that are the closest to North America. And they are 127 million years old. That's pretty old. Okay. Now let's look at these ones a little bit closer to that ocean ridge. 81 million. Okay, so they're getting younger as they're getting closer to the ridge. Let's look here. This one's even closer. 23 million years old. Holy man, we're getting really close. And what about this one that's right on the ridge? 1 million years old. Now, if you were a good predictor of patterns, what do you think is going to happen as I get closer to Africa? Well, there's 15 million, 76 million, and 163 million. So all of the rocks right on the ridge are very, very young. I mean, I know a million years seems like a lot, but in the history of the Earth, that's very little. And the ones close to the continents are super, super old. Now, what do you think's happening here? Why are the rocks really close to this volcanic mountain range so new, and all these ones are so old? Well, if you think about it for a second, they found that the rocks nearest the volcanoes in the middle of the ocean were very young, and then the ones that were right towards the continents were old. And as you move away from the volcanoes, the crust gets older and older. So what was happening was, it's the volcanoes all along. As these volcanoes were erupting, they were creating new rock. Because what happens to that magma when it erupts? It cools, and especially because it's underwater, it cools very fast, and it turns to new rock. Well, what happens to the old rock? Well, it gets pushed away. So the new rock, the volcano erupts, creates new rock, and pushes the old rock away. That's why the rocks right near the volcano ridge are new, and the rocks close to the continent are old. Well, you can't just push rocks away without pushing the continents. That's what continents are. So it's pushing the continents away from each other. Slowly and slowly. They soon discovered that the oldest crust was found near the deep ocean trenches, as if it were being pushed back in and then remelted. So these trenches, like the Marianas Trench, they had the oldest rock because the new rock was pushing the old rock all the way towards these trenches and then back down into them. It was also noticed that earthquakes, volcanoes, and mountains all form along the ocean ridge and other cracks in the crust. So wherever you have these ocean trenches, that's where we're getting new volcanoes, new mountains, and earthquakes. Putting all this information together allowed scientists to realize that the Earth's crust is broken into giant jigsaw puzzle pieces, which slowly move over time. So these ridges that stretch all along the world are actually big puzzle pieces, what we call tectonic plates, and we're going to talk about that in our next lesson a bit more. And these tectonic plates are always moving because new volcanoes are erupting all the time and sending new lava to push the old rocks away. Earthquakes, volcanoes, and mountains